and we should be ready to go. So thank you for taking some time out of your schedule again today to watch our webinar here on using DFM to question a quote. As you might have noticed from the invite, I scheduled this one for an hour. We've been trying our best to keep these to 30 minutes. And I thought this one might require a little extra time, but we probably don't need an hour. So I wanted to be kind of safe there and give us enough time to get through what we need to get through. As always with these sessions, you can use the questions function. The questions is the best place to ask us a question. You can type it in during the session if something comes to you, and those are either going to get read back to me at the end when we take some questions, and at the same time, at that point, at the end of the presentation, you can use the raise your hand function, and we can take some questions live over the phone if that's something that you prefer. So if you think of questions, ask them through that questions feature. Try to use that and not the chat. It's a little bit easier. So the questions feature, and then the live questions at the end, if you have them and you want to hold them to that point, that would be fine also. So here's what we're going to do today. It's pretty simple. I've got two scenarios that I've outlined. One is, and I think it's the more typical situation where we get quotes back from suppliers and they have not a lot of information on them. So, you want to buy 5,000 of part number 123, they're going to cost $6.25. Do you want them? And so I've got a scenario laid out around that. And then I've got maybe the more unusual situation, but the situation that we probably all want to be in, which is where we're working more cooperatively with our suppliers to get much more detailed information, and we can dig down into all of the details of the quote then using the DFM tools. So the thrust of this is going to be to outline kind of each of those scenarios, show you the issues associated with them, and then how we're going to use DFM to interpret and challenge that quotation. And then again, at the end, we'll take some questions or comments. Can everybody hear me okay? Yep. I'm getting some feedback from something. Sorry. Maybe we can mute everybody's lines. Maybe I'm just getting feedback from myself. So what do we know about supplier quotations? Well, we know that they come in many shapes and sizes. They contain varying degrees of information, right, depending on how closely you're working with your suppliers. And I think at some points that makes them somewhat difficult to understand because you don't really know what the supplier's telling you. And I have a few things in here that will kind of highlight and illustrate that. A lot of times they're based on the supplier's interpretation of what it was that you wanted. So if you're, sort of blindly sending out masses of quotes to 3 suppliers to get feedback from them on cost, then you're probably not engaged in a dialogue about what you actually wanted, and so they might be misinterpreting things and causing the quotes to be maybe higher or in some cases lower than they should be. And I think the next bullet there is an important one to take away from this is they're not always right. They might have missed something. You might have missed something. So a lot of, in getting good at doing this with DFM, you have to develop a confidence in yourself that you feel good about your estimate. And when a supplier quote comes in and it's 3 times higher than what your estimate is, that doesn't mean your estimate using DFM was wrong. It means that there's some opportunity for the next bullet, which is questioning the details. And that ultimately is where the cost savings are. That bottom bullet there is pretty true. The money is in the details. So when you can get to that point, that's where you can see sometimes some significant cost savings by understanding all of the details. So what I have then is a sample part here. This is an aluminum die casting. You can see what we know is it weighs just under 2 pounds. And I've got quotes for a variety of different production volumes, but I just picked one so that we could be consistent with our approach to this all the way through. So I've done the analysis, and all the numbers that you'll see here are based on us looking at a production volume of 200,000 parts. And so what I have in this portion of the example is 4 quotes from 4 different suppliers for the same part. Now, you're going to have to accept my apology for the graphics that we're going to see on the next few slides. These are scans of faxes of quotes that we have for these parts, so they're a little bit difficult to read, but what I've done is pulled out from the quote the important information that we're going to look at and discuss. And so here's quotation number 1 from a supplier, and you can see I'm looking here at the 200,000 production volume line item with, in this case, 2 cavities, and they're telling us what the unit cost is here, $3.51, and you can see I've highlighted that over here for us. They've got the material cost that you can see there, $1.80. Tooling down here is at $59,778. They're going to run it on a 900-ton press, and they're telling us the tool life has 120,000 shots. So I'm going to say that's on the the low end of what sort of information we would typically get from a supplier. I mean, I've certainly seen less. Things like the machine size and the cost of the material sometimes are not broken out separately. You simply get, for 200,000, they're going to be $3.51. So that's quotation 1. The second quotation from a different supplier has similar types of information on it. Their piece cost is $6.09. You don't have to write all this down if you're following along closely. I got a slide at the end here that sums it all up. They're citing a material cost of 92 cents, a tooling cost of $72,000, 950-ton press, and 125 shots for the tool life. Quotation number 3, again for the same part here, $6.19, $2.62 as a material cost, $22,500 for a tooling investment, and a tool life of 90,000 shots. Now, it's a little bit hard to read, but the note here says tooling to be replaced by company as needed. And it doesn't tell us what that cost is, so one thing to note right off the bat here is they're telling us the tool life is 90,000 shots, and it's a single cavity tool. Well, our tooling investment isn't $22,500, right? That's if I buy 2 of those, I'm only going to get 180,000 parts out of those tools. Now, maybe I can limp to the finish line and get the 200,000 parts out of 2 sets of tools, but my tooling cost is really twice this number in this particular quote. And then finally, sample quote 4, we see a similar thing playing itself out. A piece cost of $4.55. Machine size 280 tons. They're quoting it as a single cavity, $30,000 tooling investment for 60,000 shots now, with a tool replacement cost, they tell us over here, of $23,000. So again, I do the math here and figure out that I have to spend 30,000 plus 2 times 23,000 to get in the neighborhood of the 200,000 parts that I want to produce. So I'm going to pull all this together on this next slide, and it's a little bit of an eye chart because of the way all those came out. But here are all of those results presented on one page. And so what you see here are the results that I showed for quotation 1, 2, 3, and 4. And I guess the important number, the one that everybody wants to focus on, is the piece cost. So it's $351, $609, $619, and $455. Now I went ahead and did a DFM analysis of this, and we'll get into all the gory details of it as we progress in the presentation. But here are the results from our DFM Concurrent Costing software. So we're at $5 and call it 42 cents for a piece cost, $2.46 for a material cost, $40,000 for tooling, a 600-ton press, and 100,000 shots. But it's a 2-cavity tool, so I can make the 200,000 parts that I want to need, that I'm requesting on this one tool. So $40,000 as a tooling investment. So our experience with all these online sessions that we've done so far is that it's always interesting to get audience feedback at this point. So I've got a poll question that I'm going to ask you at this point. So I'm going to launch this poll. And if you would go ahead and make a selection, I'm simply asking you, based on the information that you've got from DFM and looking at these quotes, which one would you pick? And so go ahead and take the time to make your selection. So far, about 20% of you have voted. So go ahead and keep clicking away here if you would. It's kind of unfolding in an interesting sense, I guess. I'm going to give you a couple more seconds here to make your selections, and then I'll close the poll and show you the results. So we're coming up on 3/4 of you here have made a selection. Again, I'm just going to give you a few more seconds if you wouldn't mind taking a minute to go ahead and pick which one of those you want to pick. Okay, so I'm going to now close that poll and share the results with you. And so I don't know, am I surprised or not that the winner, quote unquote, is the low cost one? And I'm going to show you in a second what I picked, which is actually interesting in terms of the result. So quotation 2 gets 17%, 3 comes in second. So if we pick these in order, we're going 1, 3, 4, 2. So I'm going to hide that result, and now I'm going to show you what I picked. I picked number 2. So that was the one that came in second. So I picked number 2 because I discounted number 1, which was the lowest piece cost quote, as either they missed something or they're hungry to get the business and they are going to really take me out behind the woodshed when I come to them and say, oh, I want to add another hole, or I want to take a hole away. That change, once they've got their hooks into me, is going to cost me dearly in the long run. And so I'm going to go with the one that, if I look at now the difference, so now keep in mind, and this is important, and we'll get into this as we go through it, that this is the price, $6.09 at the piece level. This $5.42 is the cost. And so the difference in this case between the cost and the price is coming in at 12.3%. So I have to ask myself, is that a reasonable profit margin for my supplier to be charging me, given the market that I'm in, the environment that I'm in, how competitive is, whatever else is going on, and then decide whether or not I think that's fair. I chose to think that that was fair in this case. However, I should have put it in italics or made asterisks, or however you say that around it, that the tooling does need to be addressed, that it seems that they're significantly overcharging us for the cost of tooling. And I'm also paying, in a sense, for some additional capacity. They've chose to make this on a 950-ton press, and our software has calculated that the press force required would be a 600-ton press would be sufficient to make that. So maybe this supplier doesn't have that size press, or this 950-ton press is the one that's going to be available, and so maybe there's a little bit of wiggle room there. But without having a lot of detail surrounding it, it's hard for me to get into those discussions with them. So I guess interesting that the one I picked came in second, and hopefully you have some comment or insight into the majority of you that picked number 1, why you did that. Maybe I'm wrong about what that supplier would potentially try to do to me later on when changes came down the pipe. So that's kind of the end of my scenario 1 discussion, and now that brings me to my scenario 2, which is I'm in a situation where I'm using a quote form. Now, you could argue that those quotes that I saw before were a quote form. They didn't have much information on them, but this, what I'm going to show you now, is a very detailed quote form that has been used successfully by a number of different companies to attempt to get information from the supplier that we can dig down into the details and discuss things with them. And so there's going to be some flipping back and forth here of screens, so I'll apologize for that. I'm going to show you what this quote form looks like when it's blank. So it's an Excel sheet, and it's got basically 3 sections. Up here at the top, this is where we're calculating the material cost. So it's using whatever unit of measure you want to calculate an input cost and an output cost for the material. This price per unit of measure here is the cost of the material per whatever unit measure you calculate. Then it calculates an input cost and a scrap cost at a given scrap value to calculate a total material cost. So that's section A of this sheet. Section B here starts to look at process costs. So here we see things like the die casting operation, any secondary machinings, any secondary operations. The examples for this one are a deburring operation and I think it's a cleaning operation. And then it'll have a machine name here, a machine size if it's specified by the supplier, what that machine rate is, how many people, what's the labor cost, pieces per hour, a scrap percentage, and then we use a formula here to calculate what the process cost for each step involved in the manufacturing process would be. That's subtotal B, or the end of section B here. You could obviously add rows to the sheet if you wanted to increase it. And then here, there's a section for purchased components. So at the end of this analysis, this example part gets a nameplate riveted to it. And so the nameplate and the rivets are highlighted here as purchased items, their costs, and the totals of those are added in to give us subtotal C. And then down here at the bottom, there is space for us to add SG&A and profit, packaging, transportation costs, and then add all those together to get a grand total. And so I've got that information filled out for us on the example that we've looked at. And I also have a DFM analysis that we're going to use to go through the details of this. So if I go back to our PowerPoint slides here, let's look at the first section of the quote form that was filled out in this particular case. And so what you can see here is the unit of measure they've decided on is pounds. So 2.8 pounds of input material, 1.847 pounds of output material for a loss of that, a cost per unit of measure of that. So that's our input cost, scrap value, scrap actual reclaimed, and then a material cost, if you will, of $2.51, let's call it, cents. So in our DFM analysis, which I happen to have here, this is a DFM analysis that I've done of this casting. You can see here I've put in a volume of 200,000. I actually have imported a CAD model to do this. So the envelope dimensions and such have been calculated from the model. And then what I've done here is I have simply inputted the values that were on the form. So 98 cents a pound for the cost of the material, 25 cents for the value of the scrap. And you can see DFM is calculating here a material cost of $2.46 given the same input conditions. So we calculate for you the input weight and the loss, if you will, the material that's in the runners and the overflows and things like that that's trimmed off afterwards. And so given a input material cost and a scrap value, we're at $2.46. The supplier quotation here is at $2.51. I'm going to call that close enough in the grand scheme of this quote and say, kind of check the box there on this works out, this seems to be reasonable. Obviously, if there was a large discrepancy in cost there, then I'd mark this as a thing that needed to be discussed with the supplier, and maybe it could be that they were overestimating or underestimating the amount of loss that was happening during the die casting process. Maybe their scrap values were different, and we'd have that transparency into what they were looking at. We can use the DFM tool to check that against what we're being told. The second section then, section B of that cost breakdown, details the process costs. And so here you see they're telling us it's a die casting 2-cavity tool, 900-ton press with a machine rate of $110 an hour. One person at $30 an hour is going to produce 80 pieces an hour with a 2% scrap, and that's going to cost us $1.78. I can go now to my DFM analysis, and I can look at that same information for the die casting process. So as I click on the die casting line item on the machine, on the tree here, this 600-ton press, well, I can see first of all, it's selected a 600-ton press. So question one to the supplier is, why are you making me pay for a 900-ton press when it seems like a 600-ton press would do it? A 600-ton press, we're assuming one operator can handle 2 machines with automatic operation, and our machine rate is at $73 an hour with an operator rate of $25 an hour. So that gives us a process cost of $85.55. Now, if you want, you can right-click on the machine, as many of you may or may not know. You can pick Change Machine, and then you could change to the larger die casting machine that the supplier had selected here. I'll pick the 900-ton press, and I'll say OK. And my costs recalculate now, where we're saying still one operator can handle 2 machines. So $90.75 for the machine, not the $110 that the supplier's quoting me. $25 again, and not $30 for the operator, to give me if I assign half the operator rate now plus the $90.75, I'm at $103.25 for a U.S. industry average value for the rate of that machine. So I'd have to decide, am I sourcing this in a region of the country where I'm expecting that the rates are going to be a little bit higher, or is this in an area where the supplier ought to be more in line with what I think those costs are going to be? I can always check this box for automatic selection, click calculate, and get back to where I started. So we're calculating then at $85.55 a process cost of 51 cents. That's compared to, if I flip back again here, a process cost that the supplier's citing me of $1.78. So that's a red flag for me. That process cost needs to be addressed in some form. And so there's really only 2 things that I can look to here, right? There's the input rate, if you will, of the equipment, so the machine rate plus the operator rate, so that $140 an hour versus the $85.55 where we think we ought to be on average. Or there's the cycle time, so the supplier here is telling us 80 pieces an hour. So if I do the rough math on that, 80 pieces an hour is 3,600. Divide that by 80, I get 45-second cycle. So that's a nice big fat round number, and that's typically what you see on a lot of quotes. Nice, if you get that information, nice fat estimates of time. We can click on the die casting operation here, and we get a full detailed breakdown of the cycle time as calculated by our software. We're calculating a 35-second cycle. So in this case, not only is that process cost being done at a higher rate than we think should be necessary, they're also, in our opinion, overestimating slightly the cycle time. And that would be a point of discussion with the supplier that we'd want to look to potentially save some money on this quote. You can see here I put a note in here yesterday when I was doing that about what the cycle time calculations ought to be. So at a 35-second cycle, we're looking at approximately 100 pieces an hour, not the 80 pieces an hour that are being quoted to us by the supplier. We also happen to be running, and this is just our default, at a 0.1% reject rate. If we wanted to, we could say, okay, well, we'll give you the 2% because we know that something's not, something difficult about that process or whatever the case may be, and we can click calculate, and I can see that, that adds about 4 cents to the cost of my part by reflecting that new inefficiency or that reject rate. It's detailed here in the reject calculation. We don't add that to the process cost where it's being done like that on the spreadsheet. It's broken out separately. So again, we were at, I can't remember what it was before. Let me unlock that and click calculate. So I'm back to a process cost of 51 cents, call it 56 cents if I add the nickel in. The supplier's telling me it's $1.78. So that's definitely an area where I'd want to look for some cost savings. Now that same argument then can be played out all throughout the secondary operations. So you see there's a face milling operation, a drilling, a tapping, a deburring, and a wash and degrease. And again, we've got rate and labor information, pieces per hour information, and then estimates of scrap values provided by the supplier. And so if I won't go through all the details of it, I think you get the idea now. If I click on our DFM result here, you can see this is our estimate of the cycle time for feeds and speeds. I could divide 3,600 by that number. That gives me the pieces per hour. I could compare that to the supplier's estimate, and also I've got 64 cents, and I can compare that 64 cents here back to the 67 cents that the supplier is telling me that face milling operation is going to cost, and I can decide, given the cycle times and the rates, whether or not I think that individual cost is in line. At the end of the day, they're calculating a process cost here of $3.93, And in DFM, if I click up here at the top, I've got a process cost total of $2.88 for the cost of this part. So there's definitely some area for negotiation there when it comes to looking at the process costs for the part. Now what I've done to add in the next piece of this is, well, let me show you the spreadsheet first. So now we go to section C, and in section C here you can see that we're adding these two items, a nameplate that has been assigned 30 seconds of labor time at $45 an hour with a piece cost of 50 cents, and then two rivets to hold them in place that cost 25 cents each, have 0.25 minutes of labor and cost 15 cents each. And so each of those now are giving us a total of $1.66 for the cost of adding those rivets to the casting and the nameplate. And so in DFM, what I did was I added an assembly fabrication. So this is an assembly fabrication analysis of this assembly, where I've added, what I would consider to be some fairly detailed steps here. So I'm setting up an assembly jig. I've captured the labor here of acquiring and inserting the gear cover. Now this gear cover has been inserted as an analyzed part, and it's coming from this tab right here. So hopefully you know that this assembly fabrication process is one that's available to you. If you didn't, maybe that's good. That's why you're here. You're learning about something new today. This is a place where we can bring in some assembly labor and add labor cost to piece costs to roll up a total cost. So here, this is the labor of inserting the gear cover into some assembly jig that we're going to then put the nameplate and the rivets on. Here I'm capturing the assembly labor of adding the nameplate, which has just been added as a part, where I've given it the 50 cents of piece cost here. And then here I'm capturing the labor. You can see I'm securing these as a riveting operation of the two rivets at 15 cents each. And then I have to take the assembly out of the fixture that I'm doing this assembly work in. And so I could go through and add that up and compare that cost to the cost that's being quoted to me for the supplier. And so this also now includes the cost of the gear cover, right? So I'm at a total cost at this point of that compared to what my supplier is going to tell me. And so if I go back to my spreadsheet, if I click on the next tab here, this is the kind of summation of all these things that we've been looking at pulled together here. So these are the quote sheet totals for sections A, B, and C. So $251 for the material, $393 for the process costs, and $1.66 for the assembly labor and the cost of those piece parts, to give me a total cost of $8.10 from the supplier. When I went through and looked at what DFM checks those section totals against, you can see here I'm at those numbers. That's what we just looked at on the DFM analysis, and so I'm at $6.59. Now, the really important part of this is that this is a cost difference, right? The supplier is telling me his costs. I'm calculating manufacturing should cost. And so the difference in cost here is 23%. And so that's a fairly significant opportunity for me to go after on this part if I want to. We haven't even got yet to the point where I've got to the bottom of the spreadsheet where the supplier's including the profit and the SG&A and everything else. And so I'm going to go to now the completed quote form. So this is the actual spreadsheet here where this data was filled out. And if I get down to the bottom here, you can see we subtotal C here. And then the supplier is charging me a 17% SGA and P. And what's interesting is, if you look at the cell, that is only applied to the production costs. So the profit is only being paid on the material cost and the process cost. It's not being paid on the assembly labor and the cost of the piece parts. So maybe that's good, maybe that's bad. That's the way this particular supplier chose to do it. You could include that in your discussion. And is 17% the right number? Well, I don't know. You have to have that discussion with them as well. But that breaks out the profit. This is the total for the labor and piece costs. So this supplier is telling me this part is going to cost me price, right? The price to me is $9.19. Now, in our DFM analysis, I have added an operation to my operation library to calculate profit. Someone actually sent me an email this morning, and so if you're on the phone, you know who you are. I'm giving you the answer to your question. You add an operation to the operations library, and it's really simple. It says process cost equals profit margin times cost. And here I've put in a profit margin of 17%, and then I've included here the cost 5.419, which is the cost here of all of the material and process steps that the supplier, so this is the way the supplier did the cost. So I'm not adding the profit on the labor that's included in this assembly fabrication analysis. And so obviously the same percentage of a lower number comes out to a lower number. So I think the profit on this ought to be 92 cents, not the $1.09 that the supplier is telling me. So even giving him the same profit margin, it's a lower number because the cost ought to be lower. And when I add all that back in, this at the top now is my total estimate of the piece cost, $7.60, let's call it, including the 17% profit margin that the supplier has told me he wants to apply. And so if I come back to DFM here and I sum that up for you, I think it's in, did I skip ahead extra here? No, I didn't. So I never actually showed you the bottom line total. So that difference of $7 and something cents to the $9 and something cents is the total opportunity that exists on the at the piece part level for the negotiation of cost on this part, which will obviously bring the difference between what the supplier is going to sell it to me and my cost to be much more in line with a reasonable estimate of profit margin to keep the supplier healthy at the same time. And so this is what I would want to bring you to in summary then, that when information is limited, DFM can be very helpful in terms of quote selection, right? Hopefully you got from my example there with the 4 quotes from the same part that, you know, a lot of times people just pick the lowest one, and is that the right thing to do? And of the others, how would you know which one to pick? And so we think being able to stick a stake in the ground around what the cost of a part should be can really be helpful in helping you select one of the several quotes that you have for the cost of a part. And then, you know, the follow-on to that we looked at was when detailed information is available from a supplier, if you can get them to fill out those quote forms, well, DFM is certainly something that can help you make sense of it. And you can really start to learn things from what you gain from supplier A and apply that to supplier B. Or, you know, gee, we've learned from the discussion with the supplier on this part that he was willing to, you know, concede that the cycle times were too high. So let's look at what that means to all the other parts that supplier has quoted us. And we see this happen all the time, that suppliers effectively are put on notice that you now have a way to understand and question the details. So they're going to be a lot more careful, let's say, if that's the politically correct term for it, when they submit to you subsequent quotes. Or maybe you can get to that area where everybody ought to be, which is to get to a point where you're working collaboratively with your suppliers so that they're giving you that information. You're just doing the check and they're making their 17% margin and you're happy because it's on a much lower number. But over and over again, the thing that it really brings it back to is that last one, that this really allows you to focus your discussions with suppliers or whoever the person may be on data and fact and not emotion. And I think that's a really important point that we want to try and stress that can be achieved through the use of our tools. So that's what I had prepared for you here today. I guess we're at a point now where we could take a couple of questions if there were any that were submitted. We can either do that on the phone or Dave Sweet can read them to me from the questions box. That would be good.
So Nick, we did have a couple questions. The first one has to do with material cost in your example. So you had a material cost in one of the examples that was less than half of the others, which could be a significant impact on the overall comparison. So would you not want to reevaluate the cost of material specifically when you're looking at these different examples.
Yeah, so let me go. I'm going to jump slides on you here. Sorry. And so I know exactly what the person's pointing out. Here you can see the material cost is $1.80, 91 cents, 262, and 237. So if we look at this slide, it kind of sums it up a little bit more. And so the question probably is, where is that coming from? And so if you look actually at the details of the quotes, that's the only supplier that quoted the cost of the material in terms of dollars per pound and not what the material cost in the part would be. And so if I go to that, it's quote number 2. Here you can see, and again, it's hard to see, but it says 0.916 dollars in front per pound is what the quote says. All of the others say it's the metal cost that's tied up in the casting. So would that cause you to want to evaluate that? I guess you could go back to that supplier and say, hey, are you telling me it's 92 cents a pound, or are you telling me it's 92 cents for the cost of the material in the part? And that would obviously be a basis for discussion. The default value that comes out of our material library would be useful in knowing whether or not that supplier was in the ballpark of what the material cost per pound ought to be at 92 cents. So hopefully that's the answer to the question that you were looking for.
Okay, we have one more question asking you to comment on what levels of markup for things like SG&A and profit are reasonable for both small orders and large orders, if you have any comment on that.
So the easy answer to that question is I don't, because the honest answer to your question is they're all over the board, right? It depends on what industry you're playing in, what the manufacturing process types are that you're using, what's the manufacturing process itself. And so what I can give you is my really, really rough rule of thumb. And that is that if you take the result of a DFM analysis piece cost and you divide it by 0.8, that should get you to something close to what a supplier quote is. And I can never remember the third grade math on it, but that's somehow different than multiplying it by 1.2, I think. Anyway, it's assuming effectively a 20%, and I'm not going to call it profit. It's SGAP, transportation, whatever else you want to throw into that bucket. And it's a really rough idea based on, I'll call it a quote unquote average volume. If you want to buy 2 of something or 1 of something, all of that is out the window. If you're going to buy 10 million of something, that's out the window too. So that's my rough rule of thumb. I think it's effective sometimes. Any other questions?
We have one more, Nick. Pretty simple question. What's the data source of the raw material used in the DFM tool?
So we get our data from a variety of different sources. We've been doing this for an awfully long time, 30-something years now. We have a real broad range of companies and industries that use our tools, so we get a lot of feedback from them around the cost of materials. And then we have some various sources online where we're pulling that material cost information from. We kind of lump it all together and average it out to give a average cost to what we're seeing. So is it representative of, in the case of aluminum, a contract buy that you might have for 1 million pounds a year of A356? No. Nor is it representative of, I want to, machine 3 parts out of some bar stock. It's probably not representative of what that material cost would be at that production volume either. So on average in the US for average production volume buys of material, that's where those cost numbers are representative. You may have noticed, and I'll give you this plug now, and then we can take another question or two if there are any, or if not, we can wrap it up. But the deadline for papers for our annual conference in June is next Monday, February 29th. If you go to our homepage, dfma.com, there's a link right on the homepage that will take you to that URL that I've typed out there, where you can submit an abstract to us for consideration presentation at our conference this June 7 and 8. So if you have some of these kinds of stories that you'd be interested in sharing, or techniques that you use to do this kind of thing with your suppliers, I think the audience as well as us would be very interested in hearing those kinds of things. Were there any more questions, Dave, or we're about out of time?
I think we're about out of time for now.
Okay.
If there are a couple of questions that come in, as we close out here, we'll answer them individually, of course.
Sure. And also, I'm guessing that if you submitted some very detailed questions that required a lengthy explanation, we're going to go ahead and email you back about what the answer to that question is. So we'll have the questions you've typed in saved, and we'll get back to you if we didn't answer it here. So thank you again for your time today, and look for another one of these coming in a month or so on a different topic. Again, I'll ask if you have particular things you want to see or things that you're interested in, please send me an email or let me know. Also, I guess I should mention, if you're interested in a copy of that spreadsheet, if you send an email to info@dfma.com, we can get you a copy of that spreadsheet. If you want to, try and use that or use it as a basis for creating your own, that you might find that to be useful. So we'll look forward to hearing from you, and thank you all again for your time.